Hola, my name is Pamela. Welcome to my channel. Today I'm gonna talk about the mechanical elements are divided into direct measuring elements and elastic measuring elements. Those of direct measuring elements measure the pressure comparing it with that exerted by a liquid with certain density and height, and they are the next. Based on the Torricelli principle, these barometers are used to measure atmospheric pressure and consist of a 1 meter tube close to one end and a container, but filled with mercury. The measurement between the level of mercury in the container and the level of mercury in the tube should be 76 centimeters. And it works as follows. Atmospheric pressure pushes the mercury out of the container, causing the mercury inside the tube to rise according to the amount of pressure exerted. Therefore, if we are at sea level, the pressure exerted on the liquid in the container will be greater than when on a mountain, which will make the mercury inside the tube rise. At sea level, the mercury inside the tube will rise to 76 centimeters, while at 110 meters, it will be 75 centimeters. This pressure gauge consists of a U-shaped tube and filled with a liquid such as water or mercury. The pressure to be measured enters at one end and the other remains open to the atmospheric pressure, which causes a pressure difference, causing the liquid to move towards the side with the lower pressure. The inclined tube manometer is based on the same principle as the U-tube manometer. The difference is that having a longer column is more accurate, since it achieves up to 0.21 mm water column of approximation, while in the U-tube it is 1 mm, which allows you to measure very low pressures. These manometers are made of a toroidal glass tube closed at one end and partially filled with mercury. Differential pressure displaces the mercury within the ring, causing it to tilt until the weight balances the displaced mercury. This is a differential pressure gauge, in which one pressure inlet is introduced into an inverted cup-shaped container floating in the liquid, and the other pressure inlet compresses the top of the container downwards so that its level in the liquid is the measure of differential pressure. The elastic primary elements are those that deform with the internal pressure of the fluid they contain. Those that I will mention below measure the relative pressure, which means that inside them acts the pressure of the fluid and outside them acts the atmospheric pressure. There are three types of Bourdon tube: C, Espiral, and Helical. The Bourdon tube in C is an elliptical section that forms an incomplete ring and within which the pressure to be measured goes. What happens is that by having a pressure inside, this tube tends to straighten, a movement that is transmitted to a toothed sector and a pinion that is connected with the indicator needle. The spiral Bourdon tube is wound in a spiral around a common axis. Expanding under pressure causes the pointer to move by a mechanism similar to the C Bourdon tube type. The helical Bourdon tube is wound as if it were a spring that, when pressure is applied, expands, and it is this expansion that is transmitted by a mechanism to the indicator needle. Spiral and helical Bourdon tubes are ideal for recorders because they provide a large free end displacement. The diaphragm is used in processes where the fluid is corrosive or of a very high temperature or viscosity, and is made of a flexible material that seals the meter's inlet. The pressure is measured thanks to the deformation of the diaphragm, without the need for it to be in contact with the meter and damage it. If the meter is, for example, a Bourdon tube manometer, it can be filled with glycerin or silicone, so that the pressure transmitted by the diaphragm can be reflected and the pressure can be properly measured. The bellows are used to measure low pressures and can be made of brass or stainless steel and has a shape similar to that of an accordion, with one end closed and the other with a hole through which the pressure to be measured enters, which will expand it proportionally. To make the bellows last longer, you can put a Bourdon tube inside. Next, I will show you a comparison table for each of the mentioned elements. The pressure measurement instruments must be isolated by their own shut-off valve, so that when they need to be dismantled, the process does not have to be stopped. It must also have its own relief valve, so that before disassembling the instrument and after having activated the shut-off valve, the pressure trapped in the internal intake is released. In addition to protecting the devices during the process of pressures higher than 25 bars. In cases where the temperature of the fluid is high, such as the measurement of water vapor pressure, the cheapest to use is the Lyre or Pigtail, as its function is to cool and condense to use water as seal fluid. And if it does not condensate, a longer pipe must be used, but has to be no longer than 25 meters, because a transmitter will be needed. Capillaries are tiny tubes that are used to reduce pressure of a fluid according to its length, and they should be installed where they are not exposed to heat and should be mechanically protected on their armors. In a project, it must be known if there are vibrations, and pressure instruments must be prepared accordingly. For example, pressure gauges with shock absorbers, or pressure gauges designed to withstand them. So, this will be all for today's video. Don't forget to give me a like and subscribe. I upload videos every Wednesday in Spanish and Friday in English. Adios! And it works, and it works, and it works, it works, and it works, Dios. And it works. The inclined,